Okay, so in this video, we'll be doing the Chapter 1 test review for pre-calculus. So first, the steps, pretty simple, pi over 2. This should just be memorization, 0, 1. X-axis is negative, so put the negative, 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 negative. This is 1, this is 0. This is 180 degrees. This is pi radians. Now fill the middle in. We could do, it's the negative 1/2 root 3 over 2, negative root 2 over 2, comma root 2 over 2, negative root 3 over 2, comma 1 over 2. Those are our coordinates, and now we can do the degrees. So this is 120 degrees, then 135 degrees, 150 degrees, and it goes, there's like a pattern, 2 pi over 3, then it goes 3 pi over 4, and then 5 pi over 6. So it's like 2, 3, 4, 5, sorry, 2, 3, 3, 4, 4, 5, 6. So 2, 3, then 3 pi over 4, then 5 pi over 6. So that's our unit circle. The next questions ask to convert 105 degrees to radians and convert pi over 18 to degrees. So usually, so from degrees to radians, it is not, it's pi over 180. But to make this simpler, we can do 105 over 1 times, right, pi over 180. But we can make this simpler by just removing the pi and then adding it at the end. So this becomes 105 over 180, which fraction form, we can do 105 divided by 180, and then we can go math frac. We get 7 over 12, and we can just add that pi right back in too. So this becomes 7 pi over 12. That is radians of 105 degrees. Now convert pi over 18 to degrees. This is much easier. It's pi over 18 times 180 over pi. So when you go from degrees to radians, pi over 180, radians to degrees, 180 over pi. So we can go pi over 18 times 180 over pi. We get 10 degrees. And that's how to convert. All right, our next one asks to calculate the values produced by all 6 trig functions. So all functions are sine, cosine, tangent, and what are the reciprocals of the other verse? So it's cosecant, secant, and cotangent. So sine theta, all these are theta. The theta is pi over 3, so pi over 3 equals, well, we can go to our unit circle, and this is the first quadrant, and we can pretty much plug these numbers in to find we can use the unit circle to plug into these graphs. So make sure to memorize this first quadrant. I'll fill it in right now. So after you memorize the first quadrant of the unit circle, you can simply use these trig functions. So sine, well, what is sine? It's the y value. So sine pi over 3, this is pi over 3, and it's root 3 over 2. Root 3 over 2. Cosine of pi over 3, well, cosine is the x, which is 1/2. And then tangent of, pi over 3. Well, tangent is sine over cosine. So it's root 3 over 2, 3 over 2, divided by 1/2. And divided by 1/2 is the same thing as multiplying by 2. So root 3 over 2 times 2. 2's cancel out, so it comes out to root 3. So root 3, 1.7. So if we want it exactly, it's equals root 3. Those how to find those 3 trig functions. Now, if we want to find the reciprocals, it's simply flipping them. So sine theta, or sine pi over 3, just flip them to 2 over root 3. This one, it comes out to 2 over 1, or just 2. And cotangent of pi over 3, if it's root 3, it's just 1 over root 3. And that's how you get all those trig functions. Okay, this next one asks to explain what happens with the tangent and cotangent functions at theta equals 3 pi over 2. So this, if you don't know, this is an exact value on the unit circle, and it is actually, so this is what it looks like, right? This is pi over 2, this is pi, this is 2 pi, and this is actually 3 pi over 2. So tangent is sine over cosine, right? So the coordinates for this would be, well, it's pretty much, it's 0 and -1, 0, -1. So the sine of this is, so tan equals sine theta over cosine theta, right? The sine is -1 and cosine is 0. Well, this is divide by 0 error, so this is undefined. So what happens when the tangent function is at 3 pi over 2? Well, it is undefined. Now, what happens with a cotangent? So cotangent is the reciprocal, so it flips them. So it becomes cotangent 3 pi over 2 equals, it equals, flip them. So just 0 over -1, which comes out to just 0. So at tangent 3 pi over 2, it is undefined, but at cotangent 3 pi over 2, it is 0. So yeah. Okay, the next one asks to match each parent function to its graph. So let's start with sine theta. Well, sine theta, which one looks, so sine starts at 0, and yeah, so this is 3. You kind of should just, know this. Cosine, well, it looks like this. So this is VI. Tangent, it goes up and right. The reverse goes up and left, or down and right, you could think. So up and right is tangent, so this is IV. And cosecant, so cosecant is pretty much the reverse of sine. So sine starts at 0, and it, goes like this. So this is a mimic of this graph, so this is cosecant pretty much. So this is number 2. Secant, sine, I was talking about sine. Secant talks about cosecant, cosine. Oh my gosh, so many things. Sorry about that. This is pretty much the other one, V. And cotangent, it goes, like I said, down and right. So this one goes up and right, down and right. So this is 1. Sorry about all that confusion. Okay, the next ones are graphing these trigonometric functions. And so first we can do this one. So y equals -1 plus cosine x minus pi over 2. So we can do A equals B equals C equals D equals. So we can tell that D is inside the parentheses and is affecting the theta, which D is pi over 2. D is pi over 2. And then we can solve for C, which is -1 because it is pretty much given. It is the coefficient almost. B, well, the B is the period, so it looks like the B in this case is 1, right? And so 1 equals 2 pi over P. So this is our equation. It's B equals 360 or 2 pi, depending on if you're in radian or degrees, over P. P is the period. So we know the B, we can solve for P here. Well, 1 equals 2 pi over X. What is X or P? Well, it's just 2 pi. So that would mean our the period goes pretty much 360 degrees, a full cycle. So B equals 1, and the amplitude is also just 1. Now we can graph our midline, which is -1, Sorry for the really bad drawing. Amplitude is 1, so it'll go here, and it'll go here. And the d is pi over 2, so that means it'll start at pi over 2, and it'll go 2 pi, the period will be 2 pi, which it will actually extend past this. So we can set up some pretty important points. So this is a cosine graph, so that means it starts at the top, so it'll start here, and endpoint will be like over here. And we know that it's going to reach the bottom midway through, and midway through will be 3 pi over 2. And at pi, it will reach the midline, and it will reach the other midline at 2 pi. So we have 4 critical points, where the 5th is outside the graph pretty much. So we can now draw this graph, right? Boom, boom. Yeah, again, sorry for this really poor drawing. And it'll continue, blah, 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 blah. So yeah, that's how to do that graph. Okay, the next graph is y equals 0.5 sine 2x. So again, let's do a equals, b equals, c equals, d equals. Really quickly, we can see that d equals 0 since there's nothing affecting it, and c, there's no coefficient, so those both are 0. B, on the other hand, is 2 because it is multiplied by 2, and a is 0.5, or 1/2. So now we can do our sinusoidal and stuff, all that. So the midline is 0, so boom, right here. Ooh. Amplitude is 1/2, so this should be right here. And it should be right here. Sorry, once again, sorry for the really bad drawings. Our period is 2, so 2 equals, this is in radians, so 2 equals 2 pi over p. So then we can just flip these, p equals 2 pi over 2. So in other words, p equals pi. So pi is here, so it ends here. That is 1 period. That is my ice machine, I'm sorry about that. So this is sine, so starts 0, ends 0, those 2 critical points, and it also intersects in the middle. And now we can just pretty much, and also, yeah, the more critical points, it hits the top right in the middle and hits the bottom right in the middle. So now we can just finish this graph. Boom, down, up, and then that's the 1 period, and then it'll just continue, blah, blah, blah. So yeah, that's how to do that graph. Okay, the next graph is y equals sine 2x, and now we are in degrees, so we need to make sure of that. So a is 3, really simple, right here. B is 2, really simple, 2. C, well, again, no coefficient, so 0. D, again, no coefficient, so 0. So now we need to find the period, which 2 equals 360 now because we're in degrees, over p. And we can, again, so 360 divided by 2, what is that? Oh, 180. So our end is 180. And now we can graph our amplitude. Well, c is 0, so this is it. So 1, 2, 3, we got this line, -1, -2, -3, and we got this line. Sorry if that's really not that visible. So this is another sine function, so it starts at 0 and ends at 0, and in the middle it cuts through, and again in the middle we got goes to the top, goes to the bottom. Let's graph this, yippee. And we can continue it, blah, 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 blah. So that's how to do that graph. Okay, now doing this graph, A equals, B equals, C equals, D equals, A equals 2, B equals 4, C equals -2, and D equals 0. So let's go to -1, -2. This is our midline. And the amplitude is 2, 1, 2, so, and -1, -2. Okay, now this is cosine, so it starts at the top, so it'll start here. And the period, so b equals 4, so 4 equals 360 over p. Flip those two, 360 divided by 4, 90. P equals 90 degrees, so it'll be here. Now, we can solve this. So, yeah, starts here, and one period ends here. And it will intersect the middle at the bottom, so it'll be around 1, 2, 3, 4. So it'll be around the middle, and it'll intersect the midline here. So it'll look like this. Boom, 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 and it will continue. Ooh, yay! So that's how to do that graph. Okay, now equation graph below. So here we have to find the equation based on the graph. So really quickly, we can tell this is a cosine graph because simply it starts at the top and ends at the top. So let's just write that down, cosine. And then we can figure out all the important data we need. So first we can find the midline. So the highest point is 5 and the lowest point is -1. So 5 divided by 2, so midline is, let's see, it is 1, 2, so this is midline, so it is 2 plus, and then the amplitude is 1, 2, 3, and 1, 2, 3, so the amplitude is 3, so 3 cosine, and then we have to find the b, and that is the period, so b equals 360 over period. Well, what does this period look like? Well, it starts from 0 and ends at 10, so 360 over 10, so b equals 36. So 3 cosine 36x. And that is how to graph that function. Okay, for our next one, we can do a equals, b equals, c equals, d equals. So our amplitude, well, it looks like the midline is 0, so this is 0. Our amplitude, well, it goes up 1 and down 1, so this is 1. Our d, well, this is the shift pretty much, and if this was a normal sine graph, it would start at 0, but since it's not, it's moved down, this d is changed, so the d is changed by -1. Now, how do we find b? Well, let's think about this. So this right here, from start to end here, this may look like one full period, but it's not because it didn't start and end in one thing. So this is -1 to 5, -1 to 5, which equals 6. And this 6 is actually just a half period. So we have to multiply this by 2 to get a full period, which is 12. So then b equals 360 over 12. And this comes out to 30. So our b equals 30. Now we can find the equation. So y equals, c is 0 and a is 1, so it's just sine 30 x and then our phase shift. So it's usually minus the theta, but here this d is negative, so it's x plus 1 to capture that. And that is how to do that question. Okay, the last page. So in this problem, pretty much we need to know 4 seconds is 1 period, and the maximum height is 10 feet. So we can pretty much start here. This can be 10, period is 4, and with all this information, the x is seconds, so this would be like 1 second, 2 second, 3 second, 4 second, 5, 6, 7, 8, 9, 10. Sorry, imperfect, doesn't really matter. This can be 5, just for, modeling purposes. And this is the height. So y equals height, x equals time. And then we can find a, b, c, and d here. So our midline, well, if the max is 10, the midline is going to be 5, right? The max is 10, and so that mean the amplitude is 5. C is 5, and it would boom, boom, boom. Okay, now B, so we know the period, so B would equal 360 over 4, and this comes out to B equals 90. And finally D, well, there is no D here, so this is just 0. Now we can sketch a graph. So if it's saying at time 0, Fox is at his maximum distance from Mr. Lindsay, so that means at time 0, it would be he'd be 10 feet in the air. So what would this mean? This would be a cosine. So let's first, instead of graphing it, let's actually draw the equation out. So this would be y equals 5 plus, because the C, 5 cosine 90x. So that's what that would look like. Now we can actually graph this. So our period is 4 seconds. So 1, 2, 3, 4. So we can draw this. And now let's actually graph it. So it starts here, 1 period ends here. In the middle, it reaches its bottom. And boom, midline, midline. And we can draw this. Ooh. Yeah, sorry, I'm not the best drawer, and let's just continue. Blah, 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 blah. You get the idea. Okay, the next question asks, if he cries every time he reaches the maximum point for Mr. Lindsay, how many times would he cry in 30 seconds? So this is pretty much, the period is 4 seconds, so every 4 seconds he will be crying, essentially, because he will be at the maximum point, blah, 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 blah. So start at 0, that he is crying because he's at 10. Next one is 4, he'll be crying. Next one is just plus 4, plus 4, plus 4, plus 4, blah, blah, blah. So it'll be 8, and 12, and 16, then 20, 24, 28, and 32. What? Nope, because it's 30 seconds. So cross that one out. So how many times is this? 1, 2, 3, 4, 5, 6, 7, 8. So how many times will he cry in 30 seconds? 8 times. All right, now this question asks, what would be an appropriate approximate value for the sinusoidal axis? This is fancy for C, and amplitude, which is fancy for A. So this is pretty simple. So if we're trying to find our amplitude, we have to find the midline, which is C. So the midline looks like it's around here, right? And we can actually find out the midline ourselves by doing the max. Let's see, so 87, 89, 89, 86. So the high looks like 89, and the low 73, 74, 73, 73, 72. So high, low is 72. Now we can average these to find the midline. 89 plus 72 divided by 2. So our C would equal 80.5. And our A, so we can just find one of these, 89 minus 80.5 to find the amplitude, which is 8.5. So really quick, really easy, just random, you put the tricky words. Finally, the last question asks to calculate all 6 trig functions for an angle in a standard position that passes through -4, 3. So our first step we should do is draw our unit circle. So boom, or not unit circle, just draw a regular circle. And this coordinate is -4, so this is on negative, -1, -2, -3, -4, and 3. So 1, 2, 3. So it would be boom, so like right here. And we would draw this and come down to the x. So this would be our theta. And now we can actually do all. So sine theta, cos theta, tan theta, then cosecant theta, secant theta, and cotangent theta. Now let's think about this. So we can use SOHCAHTOA. So first, sine, opposite over hypotenuse. So here's our theta. Our opposite is going to be 3 tall, because this is that. And our hypotenuse. Well, let's think about this. We can do, what's it called? Pythagorean theorem. So this is 3 tall, and this is -4 long, or 4 whatever. So this is really simple. It's a 3, 4, 5 right triangle. And so this becomes 5. So it's opposite over hypotenuse. So it's 3 over 5. Really simple. Then cosine theta. Cosine is adjacent over hypotenuse. Well, it would be 4 over 5. However, it's -4 over 5. -4 over 5. Then tan theta is opposite over adjacent. So 3 over 4, -4. 3 over -4. Now, how do we find the reciprocals? Well, how do you find a reciprocal? Flip them. So this becomes really simple. 5 over 3, 5 over -4, and -4 over 3. And that is the Unit 1 test review. So you should be good.